Guys, good morning. Welcome to the Flight Dynamics course. This is Professor Nehru, Department of Aerospace Engineering, SNS College of Technology. And today we are going to see the topic on VN diagram. The introduction, VN diagram also called as flight envelope, which is illustrating the aircraft performance limit operations. Like in what velocity the aircraft structure is having its limit. Once it crosses the limit, the structure will get damage or failure. It is a plot between velocity of the flight and the load factor of the aircraft, presenting the operation safety limit for a pilot and the design engineer. This critical tool for structural and aerodynamic analysis makes the aircraft fly in a safe region or in the uh, fail safe and the safe fail condition, which defines the boundary of the normal and extreme flight maneuvering operation, which ensures the aircraft safety and compiling, which is the aircraft regulations. Right? In this graph, at zero uh, speed to maximum speed and zero load factor to the maximum load factor, we have the silent features, points of A point, B point, C and D and E, which is a positive factor and the negative load factor, and the stall region we can discuss in this course. So load factor in a flight, usually we have the lift, drag, thrust and weight of the aerodynamic forces, and the combination of lift to weight ratio is called it as a load factor. It is identified in the n, small n. They indicate the stress experienced by an aircraft, how much lift and how much structural weight is carried out. N is 1 during steady level flight. No additional stressors is acting the aircraft. So higher load factor during climb condition, turn condition or drive condition, it will faces very high load factor. In steady level, it is no additional stress is carried out. Negative load factor during inverted or downward maneuvers, it takes excessive load factor may lead to which is producing the structure to get failure. The major components of the VN diagram is positive load limit, that is a positive limit load factor, negative limit load factor, design speed, that is VC, maximum diving speed VD, stall speed, maneuvering speed. The positive limit load factor is can be aircraft where the maximum stand can be done. This is a maximum limit. A negative load factor allowed to fly in the inverted condition. The cruise condition during the safe of the operation speed is normal condition at this range. Absolute maximum speed before structural get failure. Stall speed minimum when the speed of aircraft is steady level or steady flight. Maneuvering speed where the aircraft have maximum speed for about the control inputs. So stall speed versus and the load factor and its importance. Stall occurs when airflow separates from the wing surface, whereas the stall speed increases with load factor during due to the increase of wing loading. The key element in the VN diagram respects the minimum speed operation, where the higher weight increases, stall speed increases. Reducing the speed below the stall speed, which causes the loss of lift in the aircraft, which represents the bottom lift boundary of the flight envelope curve. Next, coming to the positive and negative load factor. Positive load factor represents the upward aerodynamic forces, whereas the negative load factors occurs during inverted maneuverings at the flight, spin, or diving conditions. The structural limits of the positive and negative load factor specified by a design for individual aircrafts. The modern aircraft have symmetric or nearly symmetric limits of both positive and negative load factor. The critical for aerobatics and military aircraft as a major challenge and design criteria of this positive and negative load factor, which ensures the structural integrity during the extreme flight conditions. Coming to the maneuvering speed of VA, at what condition this designed aircraft can be fly, and maneuvering speed is the maximum speed of the aircraft where we appropriately we can control its deflection of during operation. Below the maneuvering speed, stall occurs before structural damage. Above maneuvering speed, control input may lead to excessive load. Depends on aircraft weight and flight condition, the critical for turbulence and extreme maneuvering operation. Representing a key operation limit for the pilot, which helps to operate in the maneuvering speed VA. Coming to the maximum diving speed of the designed aircraft is the absolute speed limit for the aircraft. Beyond this maximum dive speed, it is a very risk for the structural. Also, it makes to either flutter or the deformation, which defines the during certification test the safety margins, which represents the far right boundaries of Venn diagram, which exceeding the maximum dive speed can cause catastrophic failures. The model system helps to prevent pilot from the reaching the maximum dive speed, and the gust load in the Venn diagram represents the result from the sudden changes in air velocity can increase or decrease the load factor rapidly during maneuvering. It includes critical gust line in the Venn diagram. The vertical gust impacts lift and stress in both wing and the fuselage of the aircraft, and this design accounts for gust load to prevent failures and avoid damages. The importance of the operation in turbulence weather conditions. Next to the limits and ultimate load factors. Limit factors, the maximum load of the aircraft withstand repeatedly, and unlimited and ultimate load is 1.5 times of the limit load factor due to the maintaining a safety margin. Exceeding unlimited load leads to structural failure used in certification tests to ensure durability. Both limits shows on Venn diagram for design evaluation, guiding safety standards and operation procedures. Finally, coming to the applications of Venn diagram, the one is define operational boundaries of for the pilot, both normal and extreme condition. It helps to design aircraft for optimal performance and safety. It is also more essential in structural certifications and testing. Used to evaluate gust response and maneuver capabilities. Also prevents unsafe operation through speed and load factor controls. Finally, this is used in pilot training to understand flight environment constraints. Thank you guys. We'll see you in the next class.